Okay, good day everyone. Today we will going to discuss about our lesson 5 in our chapter 3, which is illustrating your T distribution, and for lesson 6 we are talking about percentile under T distribution. Okay, so first what we're going to have is your how to illustrate your T distribution. So before anything else, we need to know first what are the learning outcomes that we have in this lesson. First is your illustrate T distribution, of course. B is to construct a T distribution, and C is to identify regions under T distribution. And of course, we have here the following discussion, which is what we are going to discuss right now. So, for example, we have here, first, we need to discuss what is T distribution. So, by the way, when we say T distribution, or sometimes called students' T distribution, so it is a set of distribution models that was formulated by William S. Gossett. Okay, so under his distribution, Gossett assumed that the samples were selected from a normal distribution. What do we mean by that? On our chapter 2, we have already encountered your Z distribution. But when we say Z distribution, more likely we're dealing with a population. And that is why we are always assuming that the curve will always be equally distributed. So what's the purpose of your T distribution? Number one, T distribution is commonly used when we are dealing with samples. So however, samples from a non-normally distributed population can still be approximate the T distribution, provided that the distribution is bell-shaped, meaning when we say bell-shaped, it is symmetrical, and at the same time, the distribution is, the data is equally distributed. So hence, T distribution is very similar with a normal distribution with the following characteristics. Okay, we have, these are the things that we need to take note. Okay, number one, it is an unimodal, which means that the mean, the median, and mode are all equal to 0. Okay, so remember that in your Z distribution or your Z table, remember that your mean is always equal to 0, and that is located at the center. So it is symmetric over the axis, T equal to 0. Okay, when we say axis, as you remember, the normal distribution that we have last time is in bell shape. So your remember that the horizontal axis, which is located below here, these are your Z values are located. What are the Z values? These values is represented by 0 at the middle, and of course it flattens indefinitely to the right and to the left. Okay, so 0 indicates your mean. Of course, wherever your mean will also be your mode and your median. That's why it is located in the middle. Okay, so this also Z distribution will be again separated, or when we are using or dealing with samples, most commonly what we are using is the T distribution, and instead of Z values we have this what we call T values. Okay, this is, instead of Z values, this is what we call T values. Okay, what's the difference between the T values and the Z values? Okay, so number one, your T values uses the degree of freedom. Okay, we will going to learn later on what is degree of freedom. Okay, now but right now we will going to continue with our discussion. So third characteristic is that its distribution is a bell shape, of course, because it follows the concept of your normal distribution. Okay, fifth, the curve is asymptotic with the horizontal axis. So if you remember the characteristics of your z distribution, again, the curve is also asymptotic to the x-axis. That is, the curve extends indefinitely in directions. So when we say direction, we're talking about the left and the right directions. So when we are going to formulate this one, we are going to have this one going indefinitely approaching the x-axis, but will not going to touch the x-axis. That is your, I'm sorry if I'm not giving you a bell shape right now. Okay, let's do that again. Okay, so when we say t distribution, again, this is our needle. Okay, again, it extends indefinitely to the right. Same goes with your same goes with your extends to the left, and then extends, of course, to the right. Oh, what happened to my... Okay. Okay, now, as you can see, all the properties or the characteristics of your t distribution is all the same with your z distribution. Let's check. Okay, now, so they also depend on the degree of freedom. That is again the difference between your z distribution and your t distribution. So degree of freedom is denoted by df. Okay, it is represented by the letters df. Okay, the degrees of freedom is given by df is equal to n minus 1. Okay, here it is. This is the n minus 1. Okay, so whereas n is your sample size. Okay, so degree of freedom is measured by n minus 1. Okay, so let's continue. So as you can see here, this is an example of the illustration of your having a degree of freedom and your normal distribution. So take note that your normal distribution is the gray one, and then all others color in the curve, or which represent your t distribution, is having a different degree of freedom. The first one has a degree of freedom of 1, which is the red, and the degree of freedom 2, which is the blue, and then degree of freedom 5, which is equal to 5, which is the green, and of course degree of freedom 10, which is the yellow, which is the yellow. Okay, so as you can see, as the degree of freedom becomes higher or becomes greater, it approaches your normal distribution, or the standard normal distribution. So for t distribution, the t value is given by the formula. Let's have another slides. The formula t, where is that for a while? Okay, now let's continue. For the formula, t is equal to x bar, which is your sample mean, minus your population mean over s divided by square root of n. Okay, what is s? S, whereas, take note, mu is the population mean, this one. Okay, s represents your standard deviation, n represents your sample size, and your x bar is of course represent the sample mean. Okay, so we will going to have an example computation for that. Okay, so for example, we have here let's have a computation regarding that. So for example, if we have the values such as, we will just going to take this one. Okay, so for example, we have your sample size. Let's get this one, go back to, okay, your sample size is equal to 50, and then we have standard deviation is equal to 5. Okay, and then your sample mean each is equal to 10, and your population mean is equal to 25. So what you're going to do is just simply what? Simply substitute all, so that we will going to get the value of t. So this is will be equal to sample mean, of course, 10 minus 25 over S5 divided by 50. Okay, to take that, we have the following. Square root of 50 is, okay, we will going to get the values before below. Square root of 50, 5 over square root of 50 is equal to 0.71. So 10 minus 25, that is negative 15 over 0.71. Okay, so negative 15 over 0.71, we have, let's have negative 15. Where is the negative sign here? Okay, negative 15 over 0.71, and that is negative 21.126765. So negative 21 or negative 21.13. This is your t values. But anyways, our t values most likely are located or having a values which is somehow we will just going to settle with the smaller values. Okay, so this is how you're going to compute your t values. Okay, so that is for our lesson 5. Now we will going to continue with our lesson 6. Okay, and that is, now we will going to utilize the t values. So of course we are going to use same with your z values before, or your z table before. We have what we call the t distribution, and under the t distribution we have this what we call t values. Okay, let's have that. So we have, and by the way, the learning outcomes for this is that we must identify regions under the t distribution, and of course identify percentiles. We have already discussed percentiles before in our z distribution. Now we will going to apply that to your t distribution. Okay, so we have now for the explain part. Of course, most of your lessons are located here. So when you want to find percentiles for a t distribution, you can use the t table. Okay, so before in your z distribution we have the z table. Now in your t distribution we have the t table. So going back as a review, remember always that the percentile is a number on a statistical distribution whose less than probability is the given percentage. For example, 95th percentile of t distribution with n minus 1 degrees of freedom. Freedom is the value of whose left tail less than probability is 0.95, in whose right tail probability is 0.05. And take note, where did we get our values here? So 0.95 indicates your 95 percentile. What do we mean by that? Remember that we have here, for example, this is your t distribution. So when we say 95%, that means those are the values which are 95 and below values. So that means, for example, this is only an example illustration. If 95% is located here, the values of 95% or 95th percentile are composed of the values which is 95% and below. And it has a right tail probability which is composed, of course, of 5%. Okay, we will just going to use the orange one. So this is your 5%, and the black one represent your 95. This is the 95%, and this is your 5% or 0.05. Okay, so let's continue. Okay, so here illustrated is an example t values. So take note, there are also different t values also. So as you can see, the degree of freedom that we have here ranges from 0 to, actually this is only for 30 until 30. And we have here 0.1, 0.05. So take note that T sub A depends on the percentile that we will going to have. So if as you can see, if T of A is equal to 0. T of A, and A represents your this one. Okay, the 0.1, 0.05, 0.025. How would we able to know if we were going to use 0.1? How about 0.05? Okay, so we will going to know that by their percentage or percentile. So for example, T of 0.1. Okay, so the 0.1 is from the 0A is equal to your 1 minus your percentile. Okay, or the indicated percentile or percentage. So for example, here we have here your 95th percentile. Okay, so this only means that T is equal to 1 minus 95%. Okay, because percentile is from the word percentage, which means 100. Okay, percent. Okay, so 95% is represented by 1 minus 0.95, and your A represents your A represents your 1 minus 0.95. Let's erase that one. Okay, again 0.95. Ouch! Ayaw niya. Ouch! 0.95. Okay, so 1 minus 0.95 is equal to 0.05. So when we say T of A, the T of A here is equal to T sub 0.05. So that only means that your T of A here, which is T sub 0.1, is given by your, this is from your 99 percentile or 99th percentile or 99% or 0.99. Okay, so example we have here, and again remember always when we say degree of freedom, TF is always, what we're going to use right now is only n minus 1, the degree of freedom that we are always having. So that is n minus 1, whereas n is again the sample size. Okay, so we have here, let's check if there is an example here. So as you can see here, on your leftmost side of the table, unlike before, your leftmost side of the table indicates your z-score. Here, what will going to happen is the leftmost side of the table is indicated by your what do you call this one? By your degree of freedom, while the above values of your table here is given by here your A's or your percentile. Okay, so that will be, for example, so we have here the T table above shows the probabilities for selected T distribution. You can use it to solve the following problem. Suppose you have a sample size of 10. So your sample size, again, that is represented by n, and your n is equal to 10. Okay, so when we say we have sample size of n, that means our degree of freedom is equal to 10 minus 1, and our degree of freedom is equal to 9. Okay, next. Okay, so using the table, look at the row for degree of freedom 9. Let's erase that one, also this one. Okay, degree of freedom here, remember that degree of freedom indicates your leftmost side of your column, or your row, I mean. Okay, so check 9 here. Check the 9. And then these are the possible T values for 9. Not the above values based on the percentile. So for the 99, the 99 percentile or 99 percent, so we have here 1.383, that is your T values. For your 95 percentile, we have here the 1.833 values. For your, that is your 97.5, this is 97.5, so we have 2.262. For your, this is 90%, sorry, this is 90%. For your 0.01, this is the 99%, so we have 2.821. For your 99.5%, okay, so we have 3.250. And for your 99.99%, okay, so we have, am I correct? 0.999. So 99.9%, we have 4.297. And for this one, we have 99.95%. So we have 4.781 with a degree of freedom 9. Okay? Okay, that is how we are going to look for the T values. So remember again, the values on the left side indicates your degree of freedom. The values for the uppermost side of your column indicates your percentile, which is based from A minus is equal to 1 minus your percentile. So every time that the percentile is given, so use this formula to get your A. So that means, for example, correction for earlier, when we say T sub A or T sub 01A, that only means that A, that is A minus 1, A equals 1 minus 0.90 percentile. So that is where A is equal to 0.1 or 0.10 percentile. Okay, I hope this is clear already. This is for your lesson 5 and 6, learning your t-distribution. Okay, so where 95% of the values lie below and 5% lie above. So you want the right tail area to be 0.05. Move across the table, find the column for 0.05, and you get this 95% percentile. So that is where your 0.05. So we're getting your values or the t values on your 95% percentile. Okay, I hope it is clear already. Okay, have a great day, everyone. Thank you.